Hey, welcome to the last in the Circle Theorems videos, Circle Theorems 7, 8 and 9 in this little mini series of Circle Theorems videos. The keywords remain the same as they have done in the last couple of videos. Radius, segment, chord, tangent, diameter, circumference, sector and subtended. Okay, please do look at the previous two videos for the definitions of what those mean. Now, you will need to learn these circle theorems, as I said in the other two videos as well. These are the last three. So, the first one states the perpendicular bisector of a chord passes through the center. Useful to know. Okay, we can work stuff out from that. Basically, that just means that it's the line that cuts this chord in half, all right, creates a 90-degree angle, all right, here, all right. Tangents from the common point are the same length. So if this is the common point over here, all right, this line here, this tangent, the line that's on the outside of the circle that hits the circle and shoots off again, all right, meets at a 90-degree angle the radius, as we learnt in the first video. But this length here, here to here, is exactly the same length as this length here. This is useful for congruency, useful for congruent triangle questions, which you can get in the world of circle theorems. And then circle theorem number 9, the final one, right? This is the one that I mentioned in the first video. You don't necessarily have to use these particular words. You can call this the alternate segment theorem, all right? That is good enough for your reason when you give a reason to this, or for your answer in a problem. But basically it means the angle between the tangent and the chord equals the angle in the alternate segment, okay? So if you look at this one here, right, this angle that's between the tangent and the chord, right, this angle here is equal to this one, all right? Now I like to say it's equal to the interior opposite angle inside the triangle that's created. I think that makes a bit of sense, right? Or this angle is equal to the exterior opposite angle of the triangle, all right? So that's equal to that, right? This one would be equal to this one, all right? And then this one, well, it is that one, right? That's on the straight line and it's inside the triangle, isn't it? Okay, so that's equal to that, that's equal to that, right? Another useful circle theorem to work out missing angles. Okay, now let's have a look at question number 1. Calculate the length. We're going to calculate a length here of DE, so that's this point here to this point here on this triangle. If AB, A to B, is 48.8 and the radius is 25.5 centimeters. So what we're using here, we're employing circle theorem number 7, that the perpendicular bisector of a chord passes through the center. We know that this is exactly, or cutting AB exactly into two pieces, bisecting it halfway, all right? So we are going to know for certain that there's a right angle here, okay? There's also a right angle here and a right angle here and a right angle here, right? We know that this distance here to here is half of 48.8. So 24.4 is what this D to A is. So I'm going to write down D to A equals 24.4 centimeters. Okay, we know that the radius M to A we could use, or we could use B to M if we wanted, but I'm going to use M to A equals 25.5 centimeters. And then what we'll be able to work out is this length here. Okay, now we also know that M to E, I'll write down M to E over here, me, the length of me, not actually the length of me, but the length of ME, is the same as the radius. That is the radius. That is 25.5. Okay, useful to know, all right, because we're going to need to use that a little bit later. Basically, what we're employing here is Pythagoras. Another use of Pythagoras. Again, another thing we haven't yet covered because we haven't got to the videos on Pythagoras yet, but we're still needing to use it, all right? So I'm going to get my calculator in, and I'm going to do it quite quickly again until I do the videos on Pythagoras. I'll explain them a bit better, all right? But what we want to do is work out this missing length here. So we can call that length A, that's length B, that's length C. All right, and we've got A equals the square root of C squared minus B squared. That's what's going to give us A. So let's just say that that one is, no, sorry, we're working out B, aren't we? I always make a mistake when I do a bit of Pythagoras. Not always, right? But there's B and that's A, all right? Because we have got that length, right? That's the one we have got. Probably should have done that. There we go. So we've got A and C. Doesn't matter what one we call A or B, in all honesty, right? But we've got B there, and that is going to be the square root of 25.5 squared minus 24.4 squared. Now I need my calculator for that because I don't know what that is. Square root of 7.40877. All right. So B, the length of B equals 7.408 ... Okay, centimeters. Now we know that this length here to here, M to E, like I said, is 25.5 centimeters. If we took off this 7.4 business, all right, we'd be left with what D to E is. Okay, so I'm going to do for the final calculation, D to E is equal to ME minus M to D, which we've labelled as B. Little b. Don't get confused. All right. So D to E is equal to 25.5 minus the answer that we've got on the calculator screen. (18.09). So 18.09 centimeters. Like all these circle theorems problems, this is not drawn to a scale. Okay, so don't be thrown by that at all. All right, I hope that makes some sense. I've rounded it off to 2 decimal places. It doesn't state in the question what we need to do, but that's an acceptable degree of accuracy. All right, so there's that first circle theorem, or the 7th circle theorem in action. All right, first one in this particular video. Now question 2, we've got to prove that angle CAB equals 180 minus y, and we've got to give some reasons for each step of the working. So these proof ones are tricky sometimes, but this one I don't think it's too bad. All right, we've got an angle there which we could call angle CTB. All right, and that is equal to 180 degrees take away that y, all right, because that's a straight line, right? So that angle has to be 180 degrees, and if we took away the y, we'd be left with the angle that's left over. So 180 degrees minus y. Okay, now angle, if we say that this one here, all right, is the next one that we would do. So angle TCB equals the same thing, 180 minus y. Oh, I forgot to put the reason. All right, sorry. So that's angles on a straight line. Please write the whole words. I'm not going to do that because it takes a bit of time. Then that's the same thing because this is an isosceles triangle. All right, so I'm just going to write down isosceles triangle for my reason. Okay, and then the last reason, the last thing, is this one is also 180 minus y, which is what we wanted it to be, CAO, so angle CAO, CAB equals 180 minus y, and the reason is because of the alternate segment theorem. All right, now this angle here is, that's a tangent. If we carried on there, that's our tangent, meeting the chord or radius. All right, there's meeting the chord there actually, right, but we're meeting the radius there at 90. That's kind of irrelevant. We could use that fact as well, right, but this tangent meeting that chord, there's our angle there, right, that's equal to the interior opposite angle in the triangle, right, and this angle here is equal to this angle here. Now that actually happens to be 90, right, which is good because that's a diameter, and there's our first circle theorem in action there as well. All right, so we could prove it that way as well, but I'm going with this way, right? We're using the alternate segment theorem, so that's what I'm going to state. Like I said, you don't have to use all of these words. So the alternate segment theorem. Please write the whole words when you're giving your reasons, and there you go. That's good enough. We've found what we needed to. All right. Now, third and final question in geometry section actually, which is quite an achievement because there's been a lot of them. 3 things to do. Write down the length of BC and give a reason why. So the length of BC is here to here, right? This one we're employing the tangent lengths circle theorem. So the reason, or the distance that is 8.7 centimeters. 8.7 centimeters. and then we're just going to say tangent lengths from a common point are the same. So tangent lengths okay, just put equal. Now work out the value of x. So x is here. All right. Now what we've got again is a right angle triangle. So we've got that right angle there, because when a tangent meets a radius, and that's the radius O to A, we get a right angle triangle, get a right angle. All right. And we know that's 90. We know that's 74. So we can work out that angle if we do some calculations, some just adding and taking away. So I'm going to add the 74 to the 90, and I'm going to do 180 minus that answer and get 16. Okay, so 16 degrees, x equals 16 degrees. And then calculate the length of OA, O to A. The radius is what we want, right? So we want that length. Now, what we can use to find that length, we haven't got two lengths, but we have got angles. All right, this is a trigonometry problem. All right, we're using a bit of trigonometry here in this circle theorem problem, and I've seen this more frequently now. All right, so what we've got, if we label this triangle, all right, for a right angle triangle trig problem, which again I haven't done a video for yet, but will do. We've got an angle here and the opposite length that we've got. If we use this 74, we're going to call this the opposite. Okay, and we could use that angle there if we wanted to, right? But this one's then the adjacent, okay, and then this is the hypotenuse. All right. Now I'm going to use that way of labeling it because I'm using the 74 degree angle. All right. If you use the 16 degree angle, you'd have to call that the opposite and that the adjacent. All right. Now you use SOHCAHTOA here, SOHCAHTOA. Again, I'll do this in more detail when I go through it as an actual topic. And you decide which trig ratio you need to use. So O is what I've got and A is what I want. All right. I've got the opposite and I want the adjacent. Okay. So O and A. So I'm using the tan ratio here. So that's the one that I'm interested in. So little trig triangle TOA. Okay, it's like your formula triangles for compound measures. T stands for tan of the angle, all right? And A is the adjacent and O is the opposite. So A equals, or ADJ equals, A equals the opposite, which is 8.7 centimeters over tan of 74. Okay, that calculation there will get me the length of A. So OA, as it's labelled here on the triangle, or AO, OA, equals, all I've got to do is type 8.7 in on the calculator over the tan of the angle 74. And that is it, 2.49. I'm going to round it to 2 dp. And that is the geometry section completed. That's it. I hope you've enjoyed the little mini series on circle theorems. I hope you've enjoyed the whole lot of the videos. I hope they all make sense. I hope they're going to help you in your world of maths. The next section is Pythagoras and trigonometry. Please do continue to watch, like, subscribe, share, let people know that you're using this as a resource that's helping you, if it is, and if it isn't, then stop watching it. Thank you so much. Take care. Have a lovely day.